My name is Cédric Beaune. I'm the CTO at OBO. We're a French company which is focused on building modeling technologies. Today I'm going to present you some pretty cool case study or experiment, I'd say, which I built with Benoît Combal, which is a professor at the University of Rennes 1, and also researchers at the INRA. He's right there in the room, so it might be of help if you have some specific questions. And of course, you'll find the slides on the web. So it really all started with the GMark project. So the GMark is a research project which is founded by the French National Research Agency. Well, it's focused on building workbench for concurrent executions and simulations of heterogeneous models. Basically, we are focusing on executing models and simulating those under specific conditions. But what is more important, there is something bigger than just the research project. It's called the GMAC initiative, which has broader focus, and the focus is mostly what does globalization of domain-specific language mean, and what kind of challenges, what kind of solutions, and so on. Well, anyway, it's really not the exact topic of today, but these are all the partners working within this initiative. So the initiative is open and free. Anybody can come and join and discuss with us. What is more interesting is that thanks to this and the talks we gave in different events, we met with some other researchers, and that's kind of the starting point of this story. So during one of these presentations, we met with researchers from the INRA, the French National Institute for Agricultural Research. And they were quite curious about all these domain-specific language stuff and executing models and what you could build with Eclipse. So we started to exchange with them, and they started to provide us this nice use case. The use case is about the water resource management in agriculture. Basically, water is a very critical resource for the whole planet, and one of the main consumers of water is the farming activities. And of course, the researchers in the INRA are working quite a lot on the subject. So what is this subject? Actually, in France, a cultivator has to book for water 1 year in advance. It has to decide how many water it's going to need for the next year farming activities and then book for it. Because the administration has to make sure that twice the amount of water is available, twice the quantity which has been booked for by all these farmers. And of course, the domain expert here, the INRA researchers, would like to assess and define new cultural activities and see the impact on the overall environment. So we have the cultivators, the administration, the domain experts, and all of those are multiple stakeholders, each having a specific set of concerns and different scales looking at this. So these are the kind of decisions that a cultivator has to make. So he has a farm with fields, and he has to decide which field should I use to grow what. And if I decide to grow, I don't know, corn or wheat, then how would the crop grow in my region? When will I have to add water, and how much water would it cost in the end? How many machines, people do I need to conduct those activities? So these are the kind of decisions and questions that we try to tool and to answer to. That's definitely a complex system. We're looking at an optimization with multiple factors, being the weather, the cost, the resources of the farmer. Looking at the big picture, what we'd like is using all the open data and designs from the experts, like scientific models of physical laws, and get all of this together so that we can conduct what-if scenarios. Using these scenarios, we could try, okay, what if every farmer in the Toulouse region will start to grow sorghum instead of, I don't know, corn, for instance. And these kind of scenarios are can be used to the general public or the policymakers to make informed decisions. So that's kind of the big picture here. So you can keep that in mind if you want to change the world using models. But what do we do as a community? Well, in the Eclipse modeling community, what we tend to do is we build domain-specific tools for supporting design and analysis of complex software or embedded systems, and all of this from multiple viewpoints. So it's kind of similar of what the problem statement I've just shown before. It's a complex system, there are different stakeholders, viewpoints, and so on. So the kind of same buzzwords, and that's probably what got us started speaking with INRA. So we started to wonder, okay, well, that's a nice use case, how our technologies and techniques would fare in such context. Is there something really different in building, I don't know, a cockpit, or assessing the impact of some culture in a region? So that's a big disclaimer. I'm going to present you this experiment. I'm going to speak about science, but actually I'm not really behind the science and the domain-specific science. So I'm really focusing on how to use the open source technologies to do this kind of tooling and what kind of benefits it can approach. So it's a toy subject, it's a toy technology, but it's complex enough that we can get some insight and learn something from it. So here is the basic process for the cultivator. First, he has to state his resources, being fields, machines, the people, and then to pick some climate models. Of course, if you have a farm in Toulouse, you're not going to have the same weather if you have a farm in Spain or in the north of France, for instance. And then from this, you can assign surfaces to cultures. And from this assignment, a possible planning can be deduced. So he knows that this field is assigned at the corn culture, and to grow corn, you need to have some specific steps. And so then you can say, okay, this guy is going to sow the corn on this date for this field. So you get your schedule, the possible planning. And from this planning, we can assess how the biomass will grow in the field, and how much water we need to add, if we need to add some water for this simulation. And of course, the whole point is to be able to try, tweak it, do it again, and find a better solution. So we used a couple of technologies for this, and these are the superheroes I'm going to speak about today. So we have EMF, of course, which is used to define the domain model, but also Sirius and XText to define the diagram, graph editor, or textual editors. And another guy which is not directly in Eclipse, but I am going to speak about it also, is Optiplanner. It's mostly for the analyzing part and the optimization of the model. And technologies from GMark are also used for bringing the behavioral, semantic, and the execution and simulations. But first, I'm just going to show you what the tool looks like, because, I mean, slides are boring. So I'm sorry, so it's a bit of a low resolution here. So here is Eclipse, and it's actually the GMark Studio. The GMark Studio is composed of many plugins, which helps you in defining this kind of tooling and modeling workbench. It's all open source. It's only EPL content. It's all under the EPL license. Here I have a project which is named John, and it's containing a few models. For each aspect of the design, I decided to split it in the specific file. That's a choice you could make. The first file defines all the farming activities. So we have different cultures. We have the corn, we have the wheat, or the sorghum, for instance, and the different activities which are related. So you have to sow from the 15 March to the 15 April, but only if there has been no rain since 3 days and the temperature is bigger than 10 degrees. And to do so, you need 1 tractor and 2 people. So we can just schedule the activities, define the activities which are related to growing corn using this language. And this language is actually an XText language. So it's fairly easy to add a new activity, like, for instance, EclipseCon France. And of course, you get code completion. EclipseCon France was from the 7th of June to 10 June, for instance. And then some predicates. You only have EclipseCon if there is no rain since 2 days. Otherwise, we just cancel the event in Toulouse. Doesn't make any sense. And to do so, maybe we need 300 people. So the resources here are defined here in the same language. That's the kind of resources. So what is interesting is this file is actually loaded as a model by Sirius at the left. So if I change something here, I can see it changed in the context of Sirius, for instance. If I just rename that, and I can see this element here. And I can also just look at the dependencies in between the tasks, the activities. And of course, I can also edit from here and save, and it's going to update the file back, and maybe we can only do so after harvest. And then you see the dependencies which happen. So really, we have 2 different views on the exact same model in this case. So it's using XText on the left, and Sirius is understanding what's going on the right. So we define cultures. That's basically something the INRA guys would define. And then the cultivators can design the farm in the system by specifying fields and assigning those fields to a specific culture. So here we see the content of the XText file, but as a diagram element. For instance, if I double-click, I can navigate and see these are the exact same elements. And the farmer can split his farm in different workshops, and each workshops can have several fields. Here, if, let's say, I just change the size of the field, the size of the shape is going to be updated accordingly, so that I can really see in a glimpse which fields are the biggest. If, for instance, this field is not watered, then the color is going to change. So I can quickly analyze it, and I can see the proportions of the watered, foddered, or other fields assigned to this activity. But it's not enough. So here in this case, the farm has a daily activity and a crop activity. And the crop activity is focused on the corn right now. And it's not enough because then you need some weather data. This data is here represented as a model. So I have a CSV file. And we are loading the file as a model, and so we are displaying it in Sirius as a table. So these are the climate data of an area near Toulouse. And we can see that for each day, the amount of rain, the temperature, and the ray exposition for the area. And we reuse some of the capabilities of Sirius to define interpolated colors so that you can really see over time the the value changing and the color changing from green to red or from white to purple. So now we have the activities in the XText model. We have the exploitation, we have the weather data, and so the next model is the schedule. So I can launch the computation of the schedule. Well, it's right there. It's a bit small. When I launch the computation, we are using then a solver which is going to say, okay, which resource is used to do what at which time. So the resources are the people or the tractors. And here we can see the schedule for each field and the activities. So on the 15th of March, John and me, we are going to use the tractor and sow the field NW northwest of exploitation. And so all the activities are planned like this, and of course it's not necessarily something, there's not necessarily a good solution. So if, for instance, I remove John and I say, okay, so now find me a new schedule. But the problem is some of the farming activities are requiring 2 people. And so now in the schedule you can see that, well, it's scheduled, but there's a problem, and the problem is we did allocated the tractor instead of the people. So that's definitely not a good solution here. Let's get back. So I get back to a schedule which will work. So here we have the schedule, and from this schedule we can know when will the seed be in the soil, and so when will it start growing. And we can launch an analysis so that we know how many water we need. And this is kept in the other model here. In this table I can see the biomass growth, the amount of rain for each day, and in red, the times where I need to add more water in the field based on all this weather data and this simulation. So here I need 380,000 square meters of cubic meters of water. And if I decide to try with another culture, like for instance, growing sorghum, I can just launch everything again. So if I grow sorghum, what kind of schedule do I have? So it's computing the schedule. And then I can launch the analysis. And here we only need 288. But I could also assign this to corn or wheat, for instance, and then the new schedule will schedule all the activities for every field and so on. So that's the basic idea. Using this tool, you can try new alternatives and understand what's going on. Yeah, of course, we need way more water because we have way bigger fields. I think that's it for the demo. So now I'll get back to every technologies, and I'll try to give more insight about what is especially interesting for this kind of use case in those technologies. I'm going to start with EMF. So in all these superheroes, EMF is definitely Captain America. EMF is the glue. It's basically the cement which makes everybody work together, just like Captain America, which just, well, tells everybody what they should do. And EMF is, the writer's guy. And to be honest, sometimes it is a bit annoying in its ability of being always right, but that's what EMF does. And in this case, EMF is used to define several equal models, each for a specific part of the domain. So we have one at the top, which is actually the one for the XText TSL. And at the left, you can see the one to design the farm. The other one, which keeps all the information related to the simulation. And the last one, which I called scientific, because there was so many formulas in it that it looked scientific to me. So basically, I could split this domain in several e-cores which are interdependent. And this is one e-core model. Well, this one is the schedule one. So it contains all the resource allocations and link these elements to the form and cultures that are defined in the other models. You can see that the gray-shaped ones are actually E-classes coming from the other E-packages. So a nice side effect of using EMF for such use cases is that you get an API, a Java API, which is a one-to-one mapping with your domain. And that's a nice side effect because actually you'll need to write some logic. And the logic might get complex because, you know, it's science stuff. And as it's complex, here you get a real Java API that when you change it, you get compilation errors and you can rewrite on your algorithm. The other nice side effect is that this API does not depend on Eclipse. So you can ship it and anybody can just load the data as a Java application and reuse it. And that's in a research world is a fairly good characteristic because then others can plug their own tool and easily import or export data. Another nice aspect of EMF is that it's using this concept of a resource, which is a REST-like API. And because of that, we can just do stuff and load the model in here. If, for instance, we just import the CSV file as a model directly and put it directly as such so that other tools like Sirius or EMF Compare or whatever can directly load the model and figure out what information there is in it. The next, Avenger. So what is more scary for developers than grammar and compilers? So that would be XText. So it's scary, but it's probably the most powerful Avenger out there. So when you master it and you go over this scare. And here in this case, it's, as you've seen during the demo, it's been used for defining the activities language. And in such a use case, XText really, really shine. Because honestly, this kind of information you have at the right, if I would have to design an editor, like a graphical editor to do that, it's all right to see it as a graph on the left, but editing expressions, editing predicates, it's really painful graphically. And I mean, even using a tree-like editor, it's not a good tool for the job. So predicates, expressions, conditions are all really good signs that you should use a textual syntax. Next, Avengers is Iron Man. So, yeah. So basically, it's very fancy, serious. It gives you lots of lots of tools. It's really customizable. It's a bit like the armor of Tony Stark. Like you can ask something and it's going to figure it out. But on the other hand, I can say that because I'm one of the guys behind Sirius and I'm one of the committers. Sirius also has this tendency, which is quite annoying in Tony Stark, that it has to be the center of the world, right? So Sirius has to load the models for you. Sirius has to make sure that you're using his own resource set. It's his stuff, and it's a bit like Tony Stark in this regard. So the main capability of Sirius, which is really useful here, is the dynamic editing. So we have shapes, colors, and all this stuff which are depending on the values of the model and which are directly updated when I change the model, either using a specific tool or Java API or anything else. Table editors are also very, very nice for these kind of use cases because you tend to have lots of data which is just unstructured and line as an input, and it's quite convenient to see it as this way also. But you get to also change the colors and have more analysis capabilities in the table. So. And the next part is actually when you install the Sirius Animator framework with Sirius, which is one of the outcomes of the GMark project. So you can also define an emission and run the model, execute it, and see the result. So here, the animation is just moving from day to day in the calendars and saying, okay, so we're using John and the tractors on this field on this day to do this activity. But honestly, I barely scratched the surface. I could probably speak for several hours on all the technologies which are run there. Notably, it has lots of great technology in the Eclipse ICE project and science working group with other kind of visualization which are also very good, or which could probably be integrated really, really easily. So the other project I'm more involved in because they're more in the modeling space. But as we have a model now, we could generate reports using Axelio, for instance, HTML reports, or even generate some C++ code to launch some simulations. So from this model, it's very easy to reuse this information to do something else. Using EMF compare, for instance, we could just compare alternatives, different versions of the model, and display what actually changed in the result. And that's, as I said, just the beginning. There's many more things which could be done. But I wanted to, well, put your attention on another guy. So this is Optiplanner. Optiplanner is kind of a godlike character. That's author. Optiplanner is a technology from GBoss, which is part of the GBoss project. It used to be called Rules Planner. And this Java technology is focused on helping you resolving planning problems. So what is a planning problem? A planning problem is when you need to optimize goals under certain constraints and you have limited resources. So basically, like putting out the schedule of Eclipse conference, that's a planning problem. But also, when will I seed the crop based on the culture constraints, the climate, the weather, and the people, the machine, and the fields I have? That's a planning problem also. And it's a problem which is known as an NP-like problem. There's a huge number of solutions, and most of them are useless, and going over every solution will take a lot of time. For instance, in the case of this form, for 2 years, so you have 600 days, we have like a dozen fields, 2 or 3 resources, and maybe 10 activities we have to schedule. And if you take all these parameters in account, you already have more solutions than the number of atoms in the universe. So if you just go with your naive approach, you will quickly hit a wall. And that's where Optiplanner shine. And the good news is it's fairly easy to integrate and to mix with EMF, especially since the latest versions. So this is the interface which is generated by EMF, and what I have to do is just add a new annotation like, hey, this is one of the entities I want you to adapt and to tweak to find a better solution. And using another annotation, which is called planning variable, I can say, okay, this is the attribute you might want to change in between solutions. And what will Optiplanner do is it will use the model, mute it, depending on those flagged entities, and then give it to a score function. And that's a function you have to implement yourself, which takes one solution, and which should return a score composed of a hard score and a soft score. So you basically have your logic here, which says, this is acceptable for me because there's no hard constraint which is broken, or this is not acceptable. I add a penalty on this specific situation. And just from this, the annotations and the score function, then you get a model, and Optiplanner is going to iterate and launch a score function and quite quickly find a solution which match the hard constraints, and then you will try to optimize the soft constraints. There is no guarantee it's the best solution. It can't guarantee that, but it just find a good enough solution quickly enough. And by the way, you can also make sure that it only thinks for 2 seconds, for instance, and just give me the best solution you get in 2 seconds. So what have we learned so far? So this is the basic diagram of what we did. There is Eclipse as the host of integrating all these technologies, but what is at the center is EMF and the core model. It's at the center for any tooling you have then, being XText or Sirius, and then it's the center of the API which is used by Optiplanner. It's the center of the GMAC animation. So one of the main findings you can make is that you should never ever compromise on your domain model. The more precise it is, and the more powerful the tooling gets. If you just let some weird ambiguity or something which is not exactly understood in your model, then this is going to ripple down everywhere in the tooling and in the code. This tooling I just showed you was actually made in after 3 hours meetings plus mail exchanges with the INRA and 10 days of me working on the actual tooling. So it's definitely just proof of concept, but you can look at the code on GitHub. Just keep in mind that it's a proof of concept. It works, but gives you an idea of how much effort you might need if you want this, but at a way more mature scale. And of course, I already knew all these modeling technologies, but I had to learn about Optiplanner at the same time. So technologies which are designed to build this kind of tools are actually relevant also to save water, to save this. And these technologies are relevant mostly because it's not just about stacking technologies on top of each other. It's why I call teaming them, just like the Avengers, you know. It's just you have several superheroes and you put them together, and if they don't agree, then you're not saving the world. And if you've seen the last movie, it's pretty much the plot. So, but here, they're teaming up, which means, for instance, that for Eclipse, teaming up means that every tool or plugin specify its contribution in terms of views, actions, and stuff like that. So Eclipse can figure out what this means and decide to display those in a specific way. But in the case of EMF, well, the data can be inspected by others, and the others can reflectively understand enough so that they can do something useful with this data. So that's where these tools end up being collaborating on a domain model they did not even knew at first. There are a few opportunities which could be improved. The first one being time modeling and management. For this kind of scientific use case, quickly you end up wondering how should I design time in my eco model, time intervals and stuff like that. So that would be an interesting subject. Another one is to use probabilistic models. Right now we're using the data from the last year to represent the weather. It's of course quite false. I mean, we would really like to have some kind of uncertainty on these values. And of course, you'd need it, graph, charts, and representations in Sirius, which is something which Sirius has been designed for. You can extend it to add those, but it's just not done yet. And as I said, you could use EMF compare for alternative comparison. There are a few references. Sorry, I'm rushing a bit to the end, but just a few words. If you're interested in Sirius, we're organizing SiriusCon again this year. It's a free event in Paris. It's on the 15th of November, so you're welcome. If you do something interesting with Sirius, you can also submit a talk, submit a paper, and we will look into it. And of course, do not forget to evaluate this session and give me feedback, whether you liked some stuff or whether some stuff you think I could improve on or rework. So, thank you for your attention. I'm slightly late, so I won't take any question, but I will be at the OBO booth